Hello everyone, welcome to this session on Google Cloud Platform Fundamentals. In this video, we will understand the basics of Google Cloud Platform, also known as GCP, and how it is used to build scalable cloud applications and modern data platforms. This video is designed for beginners who want to start their journey in cloud computing and data engineering. Let's get started. Before we understand Google Cloud, it is important to first understand cloud computing. Cloud computing is the delivery of computing services such as servers, storage, databases, networking, and software over the internet. Traditionally, companies had to purchase physical servers, manage data centers, and maintain infrastructure. But with cloud computing, organizations can simply rent computing resources from cloud providers whenever they need them. The main benefits of cloud computing include scalability, cost efficiency, high availability, and global accessibility. This means companies can scale their systems up or down depending on demand. Now let's talk about Google Cloud Platform. Google Cloud Platform is a collection of cloud computing services provided by Google. It allows developers and organizations to build applications, store data, process large datasets, and deploy machine learning models. Google Cloud runs on the same infrastructure that powers major Google services such as YouTube, Gmail, and Google Search. Because of this powerful infrastructure, Google Cloud provides high performance, reliability, and global scalability. Google Cloud Platform offers several important advantages. First, it provides a global infrastructure with data centers located in multiple regions around the world. This ensures high availability and low latency. Second, Google Cloud has one of the fastest and most reliable networks in the industry. Third, it offers powerful data analytics and machine learning tools that help organizations analyze massive data sets. Finally, Google Cloud provides strong security and identity management features, which help protect sensitive data and applications. Google Cloud services can be grouped into several main categories. The first category is compute services, which provide the processing power required to run applications. The second category is storage services, which are used to store different types of data. The third category is networking services, which connect and manage communication between cloud resources. The fourth category is data and analytics services, which help process and analyze large data sets. The fifth category includes artificial intelligence and machine learning services. And finally, the last category includes security and identity services. Compute services provide the computational power needed to run applications and workloads in the cloud. One of the most widely used services is Compute Engine, which allows users to create and manage virtual machines. Another service is App Engine, which allows developers to build and deploy applications without managing servers. Google also provides Google Kubernetes Engine, which is used for container orchestration and managing microservices. Another popular service is Cloud Run, which allows developers to run containers in a fully managed serverless environment. Google Cloud provides multiple storage solutions depending on the type of data. Cloud storage is used to store unstructured data such as images, videos, backups, and documents. Persistent disks provide block storage for virtual machines. FileStore provides managed file storage for applications. For relational databases, Google Cloud provides Cloud SQL, which supports databases like MySQL and PostgreSQL. For large-scale, NoSQL workloads, Google Cloud offers Bigtable, which is designed for high performance and massive scalability. Google Cloud is widely used for data engineering and big data processing. One of the most important services is BigQuery, which is a fully managed and highly scalable data warehouse. BigQuery allows users to analyze large data sets using SQL. Another powerful service is Dataflow, which processes data in both batch and real time. Pub/Sub is a messaging system used for real-time event streaming. Google also provides Dataproc, which is a managed service for running Apache Spark and Hadoop workloads. And finally, Cloud Composer is used for orchestrating complex data pipelines. Networking services in Google Cloud enable secure communication between resources. The most important networking service is Virtual Private Cloud, also known as VPC. A VPC allows you to create a private network inside Google Cloud. Google Cloud also offers load balancing, which distributes incoming traffic across multiple servers to ensure reliability. Other networking services include Cloud DNS, Cloud CDN, VPN, and Interconnect, which provide secure and optimized connectivity. Security is a critical component of any cloud platform. Google Cloud provides multiple security tools to protect infrastructure and data. One of the most important services is Identity and Access Management, also known as IAM. IAM allows organizations to control who can access specific resources and what actions they can perform. Google Cloud also provides encryption by default, meaning data is automatically encrypted when stored or transmitted. Security tools such as Security Command Center help monitor threats and maintain compliance. Let us look at a simple data engineering architecture using Google Cloud services. First, data is generated from sources such as applications, websites, or IoT devices. This data is ingested into the system using pub/sub, which acts as a messaging service. Next, the data is processed using Dataflow, which performs transformations and data processing. After processing, the data is stored in BigQuery, where analysts and data scientists can run queries and perform analysis. Finally, the processed data can be visualized using business intelligence tools such as Looker or other dashboard tools. In this session, we learned about the basics of Google Cloud Platform and its core services. We discussed cloud computing fundamentals, key service categories, compute services, storage services, networking, security, and data engineering tools. Learning Google Cloud is extremely valuable for building a career in cloud engineering, data engineering, DevOps, and machine learning. In upcoming lessons, we will explore Google Cloud services in much more detail and build real-world data engineering pipelines. Thank you for watching, and I hope you found this session helpful.